Am I audible?
Yes, sir.
Okay, okay, fine. Okay. So the next topic we are going to discuss about wires. Okay. I think you people have already studied about wires. Okay, in third or fourth semester. This is just we are going to brush up. Okay, as is there in your syllabus. Okay. So you can write down the definitions of wires. Okay, and next part you can write the types of wires. Okay, mainly we are going to discuss about types of wires with diagram. Okay, so better you first write down the about the wires have been used as a distance measuring device also in open channel since almost 2 centuries, and probably the most extensive used device for measurement of rate of flow of water in open channels. Okay, so wires are mainly two types of, one is sharp crusted and one is broad crusted wires. Okay, so those two types we are going to discuss in details. Okay, so you first write down about the wires, then we move on to the sharp crusted wire. Okay, and for this no for wires you can refer this book called Fluid Mechanics and Hydraulic Machine by R.K. Bansal. Okay, R.K. Bansal. I think you already had that book. It's a very popular and famous book. Okay, and it's very good also. You can find all the fluid mechanics and hydraulic machines there. Fluid Mechanics and Hydraulic Machine by R.K. Bansal. Okay, okay. So this diagram you have seen, this is your sharp crusted wire. This is your sharp crusted wire. Okay. This is the sharp crusted wire. You see, this is in rectangular shape. Okay. If you see these wires, suppose for a particular river, we all know the cross section of the river is somewhat irregular. Okay, then it's very difficult to find out the exact discharge in that particular section. So what we are going to do, we are going to construct a wire. Okay, construct a wire of a particular shape. Okay, then what happened, your cross section is now uniform, so these are all are constructed part, so water is flowing inside this wire. Okay, if it is a rectangular, triangular, trapezoidal. Okay, so it varies depending on the shape. So if you see here now that water is coming through that particular section, and the shape of that section we know, that is your rectangular. Okay, so using that particular equation we can easily find out the discharge of that particular section by using or constructing a wire. Okay, or you can this proper term is notches, you can also say this is your knots. Okay, so it's a sharp crusted wire. You can draw the diagram and you write down the equation. Okay, equation number 5, you can see here, you can write q is the discharge in meter cube per second, l is the length of the crust in meters, that is this length, this part. Okay, in meters, and h is the head in meters, that is the vertical distance of elevation of the wire crust and the elevation of the water surface in the wire pool. Okay, that is the difference between the this part, and if the water level is here, so this is h value. Okay, before constructing wire is very difficult to find out the discharge. Okay, you have to consider If suppose this is the level of water, you have to measure the depth of flow for each section. Okay, each section. Then you have to find out the area by considering this is a straight line, so you are not getting the appropriate value. Okay, so if the channel is small, you can construct a wire, but obviously this structure cannot be constructed for a very large river or a very large channel. Okay, suppose you have a small channel where you want to measure the discharge, so you can construct a wire and you can appropriately you can find out the discharge. Okay, so you draw the diagram and write down the equation. Okay. After the equation, you also write that Q is the discharge in meter cube per second, L is the length of the crust in meters, and H is the head in meters. Over. Okay, then we will move on to the next type. Okay. Okay, so this is also a sharp crested wire, but the shape is trapezoidal. Okay, this is the width of the channel, and this is the top width. Okay, this is also sharp crested wire, but the shape of that section is trapezoidal. Okay, and this is the equation. So you draw the diagram and you write down the equation. Okay, this is the equation. Everything will be same. Okay, only the shape is changes, so that is why the equation is also changed. So depending on the discharge or amount of water, it changes the shape of the section. Okay, over. Okay. So after this, we move on to the next one. Okay. Again, that's subcasted wire. So it's a V notch, or you can say it's a triangular one. Okay. It's a triangular one. Okay. So we don't have any bottom weight. Okay. We have only top weight. Okay. So and this angle is 90 degree. Okay. So you can say V notch wire, or you can say triangular knots also. The first one is your rectangular, second is trapezoidal, this third one is your triangular, and all the three are V notches. Sorry, sharp crested wire. And you write down this equation, that is equation number 7. That Q is equal to 8 by 15 twice G CD to the power half H to the power 5 by 2. The CD is nothing but your coefficient of discharge. G is acceleration due to gravity. H we have already discussed, okay, and Q is the discharge in meter cube per second. Okay, so this is the equation for subcrusted for triangular nodes. Okay, here the small g is acceleration due to gravity. You can take 9.81 meter per second square. Okay. CD is coefficient of discharge. Okay, H is the head in meters, and Q is the discharge in meter cube per second. So next again, this is nothing but the variation of CD with H square by A. Okay, A is the cross sectional area. Okay, so these are the sub trusted wire. Okay, so I suggest you. Okay, I suggest you to follow that book, that R.K. Bansal, for detail of that notches and wires. Okay, and to measure discharge, we have another structure called flumes. Okay, so flumes is basically used to measure discharge in, you can say, in an open channel. Suppose in a laboratory. Okay, suppose you have an artificial channel, or maybe you have a canal where you want to measure the discharge. So in that case, we can also use that flume structure. Okay, so it's something like that conversion. Then there will be a throat. Then again, you have a diversion. Okay, so if this is the channel boundary, so we can place that in between the channel, and we can measure the discharge using this equation. So you can write down this equation. This equation is for flume. Okay, and this type of structure we have in our lab. Okay, so when you come to the university, if you wish, you can see this type of structure, how to measure this discharge in a particular section using the flume. Okay, measuring flume, or you can say it's a venturi meter. Venturi flume, venturi meter is different. We used to measure in pipe. In open channel, it's venturi flume. Yes. So we are going to end our class today here. In next class again, we are going to discuss about the spillway, and then this dam break problem. Okay, introduction of dam break problem. Continue in the next class. Okay, we will continue in the next class with the dam break problem and then spillway. Okay, thank you, students.